All right, this is going to be our third and final prerequisite lesson. Starting things off with a little more on the graphing calculator. So anytime you see this is for graphing calculator. So I'm going to show you guys how we can solve a quadratic equation on the graphing calculator. So there's actually a couple different ways you can solve these on a graphing calculator, but I'm only going to show you how to do it by graphing for now. So this one comes with a little reminder. As you were solving a quadratic equation, remember this whole thing equals 0. So if we can find any values for x that produce a result of 0, we know we found our solutions. So that's why when you solve these by factoring, right, we set each factor equal to 0. And as you solve those factors, you get your two solutions because they produce zeros within the setup. So in terms of graphing, remember that a 0 translates into an intercept, right? So right here you see the 0 is in the y position, right? Think of this as y equals, and then here's our graph. So we are looking for points on the graph where we have a y value of 0, which of course is going to be at the two x-intercepts, right? These are the 2 points on the graph where your y coordinate is 0. So we're simply going to graph it and then identify the two x-intercepts that are on there. Be careful on going by looks. I'm going to show you how we don't have to go by looks. We wouldn't not want to assume that this is 1/2, even though it looks like it, because it could always be a number that's close to it without actually being 1/2. You can't even trust ones that look like this, where it looks like it goes directly through a point that's clear to you. You still got to be careful because it may be real close to it, but not exactly on it. So I'm going to show you the way how you can get these for certain for what they are. So first things first, go to your y equals button again, and I'm simply going to type in the equation that we see right here. So 2x squared minus 7x plus 3. And remember, we're using this button right here for x. So I'm going to go ahead and hit graph. And so we have our graph right there. Let me see if I can darken my background a little bit. There we go, that's better. So we're looking at the same graph that you see on their display window right there. So again, I need to figure out what that and what those values are for our x-intercepts. So we're going to go to the word right here where you see this says calc in blue. So anything that's in blue, you got to hit the blue button first. So I'm going to hit second and then calc. It's going to pull up this little menu. This is mostly where you'll go from the graphing screen, would be under that feature right there. So we're going to find the zeros of the graph. So choose option 2. Obviously there's going to be 2 of them. I got to do this process twice. So they're going to ask me a couple questions. They're going to say, what is your left boundary? So as long as you are to the left of that intercept, you're fine. Just go ahead and hit enter. And a little vertical bar pops up. And then it's going to say, what about a right boundary? So I'm going to scroll right, just enough to make sure I'm to the right of that intercept, and hit enter. And it pulls up another little boundary line right there. So it's going to say, do you want me to guess? Always hit enter when it says guess. And you can see right there we have our first 0, which is 0.5. So that was the first solution, and then I'm just going to repeat that process to get my other intercept. Even though it looks like it's on a specific value, don't trust that. It might not be exactly that value. So again, I'm going to hit the second, calc, choose option 2. So for the boundaries, so again, here's my intercept. So for a left boundary, I need to make sure that I'm at least a little to the left of that intercept and hit enter. My right boundary, I got to be a little to the right of that intercept and hit enter. So my intercept should be between the 2 vertical bars that we just created. It's going to say guess. Just go ahead and hit enter one more time, and you have your other 0 at 3. So there's our 2 solutions. So we can solve quadratics by doing that. You can actually solve any equation that equals 0 by using that method. So any equation that you ever solve, if you put everything onto one side and make it equal 0, you can solve it by doing what we just did. So let me move on here. So they do want us to do some factoring as well. So we are going to solve graphically. We're just going to confirm those answers by doing a little factoring. So make sure you always follow those directions. If the book says to, or homework says to do something like that, make sure that you do both. So we're going to graph number 1. I don't know that we're going to factor all 3 here. If we had a little more class time, maybe we would do that, but this just being a video, I don't think we're going to do graphs for all of them. But anyway, so on the first one, if you want to solve this by graphing, again, you're going to go to your y equals button. Let me clear out the old one. Type in the new one. You have 2x squared minus 8. Go ahead and hit graph. By the way, if your intercepts were outside of the viewing window, like let's just say you had a U that did something like this, right? And it like stopped right here. So you know it would continue, but you needed to see more. You just go into your window settings and expand your window settings so you can see more of the graph. Anyway, so if I want to figure out those guys, and it looks to me like it's at -2 and +2. And that's going to be the solutions, but just for the sake of practice, if I go under Calc and choose 0, I'm going to establish my left boundary, hit enter. I'm going to go to the right of the intercept and hit enter, so it's between my bars. Hit enter one more time, get rid of that shine on the screen, and it's right there at -2, just like we thought. And again, you would just repeat that process one more time to get the other intercept for your second solution. If you were going to solve this one by factoring, this is one we would, man, I wouldn't even factor this one to be honest, but we'll do it anyway. I'm just going to start by dividing everything by 2 before I factor it. So that you can see this a little simpler, but we have our classic difference of 2 squares. So we're going to say x plus 2 and x minus 2. And if I set each one of those equal to 0, that's where we get our -2 and our +2. So we can solve it many methods. That's our factoring method. You guys remember how to factor these. Numbers that multiply to be -6, they add to be -1. So in this case, I guess we are going to factor all 3 of these. I'll just go through it quickly. So numbers that multiply to be -6 would be -3 and 2. So again, we could set those each equal to 0 to get our solutions. Should end up with +3 and -2. One more on this. I'm going to show you my way on this. You may have just learned sort of a guess and check method. I'm not a big fan of guess and check because that can take a long time depending on what these numbers are. This one's pretty easy, but some could be really tough. So let me just give you my way of doing it real quick, and if you like it, great. If not, then you can use whatever method makes sense to you. But the way I've always done it is you take your leading term and multiply it into your C term. Remember, this is A, B, and C. So I'm multiplying A times C. So that it looks like this. And now I say numbers that multiply to be 6 that add to be -7 would be -1 and -6. So the only extra step you have to do with this is whatever your A value was that you multiplied into this, you now have to divide it back out. So I have to divide each of my answers by 2. And really from here, I can set these equal to 0 and solve it. And so I'm going to get 1/2 for my first solution, and I'm going to get 3 for my second solution. So that's the way I do it. Again, whatever works for you. Something I know you guys have had plenty of practice with is your quadratic formula. So this is just a quick reminder of doing quadratic formula. We've already seen how to solve these using our graphing calculator. We've seen solving by factoring. Quadratic formula is kind of your backup method. This works for all cases. The one good thing about the quadratic formula is it can leave you an answer in radical form or exact form, right? We can get an exact answer by leaving it in radical form. The graphing calculator is going to give you decimals, right? A rounded decimal. It's not going to give you exact answers. It's not going to leave it in radical form for you. And so if the directions ask you for an exact answer, we have to use this in cases where maybe it would have been just a rounded decimal instead on the calculator. So this does have a role for sure. One thing we know we have to do on these is make it equal 0 before we solve it. So bring that 2 over. We know this is A, B, and C. I'm just going to sub those into our quadratic formula. So negative B plus or minus. I got b squared minus 4ac. And then the whole thing is over 2a. When you're solving these, could certainly be a case where you're having to do this in a test question where you're not allowed to use a calculator. So just remember the basic steps on these is you want to simplify the radical first. So if I clean this up, I'm looking at 25 plus 16. Always good to watch out for those negatives. All right, I got a double negative, so that's why I said plus. So we should be looking at 41 under the radical over 4. So that's our answer in exact form. I mean, I could still type that into my calculator to turn it into a decimals if I really wanted to, but that would be as simple as it gets in exact form. If I could simplify the 41, I would, but that guy cannot go any simpler. So let me jump down to these ones. So as I mentioned earlier, you can solve any equation by graphing it and finding the intercepts, just like we talked about earlier. As long as everything is on one side to make it equal 0, we can just graph it and find the intercept the same way we did with our quadratic. So let's just try that on here real quick for practice. Go back to y equals, clear out the old one, type in the new one that says x to the third plus 2x minus 1. So here's the new one. I'm going to go ahead and hit graph. So we have a cubic function. There's only one x-intercept, which means there's only one real solution to this. So again, if we go under calc, choose 0, give it a left boundary, hit enter, go to the right of your intercept and hit enter, and then hit enter one more time, and you got your solution. So there's our solution right there. And as far as rounding goes, we can round to whatever the directions tell us to round to. But again, we can do that process for any equation that we want to solve. Jump to the next part here. So one other option if you're going to solve by graphing is if you don't want to get everything onto one side to make it equal 0, what we can do is graph this side as one graph, graph this guy as another graph, and simply find out where are they equal or where do they intersect each other. So I'll show you that one here, but I also wanted to show you how to graph an absolute value as well. So let me go back to my y equals. Let me clear out this one. So I'm going to graph my first graph of 2x plus 3. So if you go under math, which is right here, and go to the right under the number column, the first option that says ABS is absolute value, so hit enter. Pulls up the brackets, and now I'm going to type in my 2x plus 3. And then I'm going to graph the right side of the equation, my 5, as a separate graph. That's just going to be a line, right? Y equals 5. And so we're going to go ahead and hit graph. So here comes the absolute value equation. Here's y equals 5. You can see they intersect in two places, so I need to find those 2 points of intersection. Super, super important to keep in mind on this. As we solve this, when I find the point of intersection, I'm going to get an x and a y coordinate. If you look at the equation, there's no y here, right? This is only solving for x, so I would only use the x coordinate in my answer, right? It's only if you are solving a system of equations that have x and y that you would keep both or for the full ordered pair. But anyway, I'm going to go back under calc, go down to option 5 that says intersect, and hit enter. There's 2 of them, right? So all you have to do to this is wherever your cursor is closest to, that's what it's going to give you the answer for. So just put it closer to one of the points of intersection. For these questions, all you have to do is continue to hit enter. So I'm going to hit enter, 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 and my first answer is 1. Remember, you're not using the full ordered pair, just solving for x on this one. As you can see right there, there's no y value. I'm going to go back under calc, choose option 5 again, but now I'm going to move my cursor closer to the other point of intersection and hit enter, 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 and there's my other solution of -4. So that's another way of solving equations. So if it doesn't equal 0, that's the way you would solve it, right? So you just create one graph from the left side and one graph from the right side and do it that way. So if you want to try some for practice, you can. I'm going to sort of jump ahead to the next one here to keep the video moving. So we're going to get into the final page of the notes. So solving a quadratic inequality. So these become a little more tricky just because when you say something greater than or equal to 0, now you're talking about a whole area of answers, right? It's not just one specific value, it's a group of values because it's talking about everything that's greater than 0. So here we go on these ones. First things first, we're going to treat this as the quadratic equaling 0 to start, simply because I want to know where my intercepts are, right? So we're solving by factoring. So we took the equation, we set it equal to 0, we set our factors equal to 0, and here's our 2 key values, right? These are our 2 intercepts. So we're x equals 3 and -2. So what we are looking for is where is this graph greater than 0? This is where it equals 0, right? Here's the line where it equals 0, right? So where is it greater than 0? So this portion right here is greater than 0, and this portion right here is greater than 0. The portion in between is the piece where it is less than 0, right? So the x-axis is our 0, right? So the portion of the graph that is above the x-axis is going to be our solution set. So there's 2 ways to do this. One is just by looking at the graph, right? I can already see, so here's -2. So I can already see the x's that are less than -2 and the x's that are greater than 3 would fit this description right here, right? They're above the x-axis. So I already know my solution set just by looking at the graph. But if you weren't sure, if you didn't have a graph in front of you, or especially for some of the more complicated ones that we're going to do in the future, this is really the process that we're going to take, right? Is we're going to do interval testing. So we're identifying our key numbers here, which are the x-intercepts, and we're simply going to test a number in those 3 intervals to see whether the values are overall positive or negative. So I want to test a number that is less than -2. So if I were to take any number below -2, like -3, plug it into the original equation here, am I going to get a positive or a negative? So if I plug in any number below -2 in here for x, I'm going to see that I get a positive result. If I pick any number between -2 and 3, probably 0 would be the easiest. So if I plug in a 0 for x, you can see that I'm going to come out with a negative result. I would get -6. So that portion of the graph is negative. Anything greater than 3, so to pick a number like 4 and plug it in for x, you're going to come out with a positive. result. So what this tells me is this area and this area is the portion of the graph that is greater than 0, right? Those are the positive areas of the graph. So in terms of this graph, here's where it's positive, here's where it's negative, and here's where it's positive, right? So we can see, and so here's something that's super important. This says greater than or equal to 0, so that means I do get to include this number, right? If it just said greater than 0, I would not include the -2 or the 3, right? But because it says greater than or equal to 0, I get to include the zeros, which are those guys. So everything, the x's that are less than or equal to -2, as well as the x's that are greater than or equal to 3 would be my solution set. Of course, we want to be able to write that in interval notation. So we're going to do something like this. So from -infinity up to -2 in union with, so if you have to write more than one group of answers, we put a little u in between them. This stands for a union of the two sets, just means they're all coming together as part of our answer. So the x is greater than or equal to 3. Should have put a bracket there. So x is greater than or equal to 3 are going to go from 3 to infinity. And so that's how we're going to want to write our solution set. So this is really going to be the appropriate way to write our answers. That's what we're going to need to get used to. So these next couple I'm going to kind of show you just for practice, so you can sort of hang with me on these if you want to. So again, we're going to solve this inequality. As I mentioned up above, I could do it with the graph or by hand. You could do it either way, really. So I'm going to show you both real quick. If I were to solve it by hand, I would first figure out my key numbers, my x-intercepts, by factoring. So I can see that my intercepts are 1 and 4. All right, so those are my key numbers. So I would have to do some interval testing to see where this graph is positive and where this graph is negative. In this case, I'm actually now looking for the negative portion of the graph because it says less than 0. So if I picked any number right here, right, like 0, and plugged it in for x, overall I'm going to get a positive result. If I pick any number between 1 and 4 and plug it in for x, I'm going to get a negative, and any number bigger than 4 is going to give me a positive. All right, so that tells me what my graph looks like within those 3 intervals. In this case, I'm looking for the portions that are negative, right, less than 0. And there's no equal sign on this, so I do not get to include my intercepts in my answer. So I simply want to say that it's this piece of the puzzle right here. So the numbers from 1 to 4 would be the best way to write that answer, right? And again, I'm putting parentheses because there's no equal sign right here. So I'm not allowed to include those intercepts. You can do this with any graph. So you could do it with a cubic function as well. So we'll just mention this. If I were to graph this, we're not solving these by hand right now. In fact, I'm not even sure that you could. So when you get into the higher order functions like this one, for now we're going to solve only by graphing. So if you were to graph this in your calculator, here's what it would look like. Right? So you can already see where it's negative, positive, negative, positive. Right? So the portions of the graph that are above the x-axis are positive. Below the x-axis is the negative portions of the graph. So one thing you would have to do in order to be able to write your answer for these, which would be something like this, is you would actually have to go under that feature that I showed earlier in the video that says Calc 0 and figure out what are the zeros of the graph, right? So you have to identify what those intercepts are first. Then you can identify your solution set with something like this, right? And so in this case, we were identifying the positive portions of the graph. So this piece right here, as well as this piece right here, is what you're seeing right there. All right, that's the positive portions of the graph. That's how we would write our answer. So that's it for our third lesson.